Hello, I am Tyler Linder, and this is my second lab report for Physics 2211 for fall 2020. And the title of this lab report is Motion of a Falling Object. First up, we have the introduction, and just like the title, the topic of this lab is Motion of a Falling Object. And the procedure for this lab is to first record and observe the motion of an object falling. The object that is falling must weigh significantly less than a rock. Once you record the object falling, you have to upload it to Tracker and observe the object's position and time during its fall. After that, you recreate the object's position versus time on GlowScript. The fundamental physical properties of this lab is first Newton's second law, then gravitational force, and after that, drag force. Newton's second law would be that net force is equal to mass times acceleration. The gravitational force is equal to gravity times mass. And for drag force, it will be that drag force is equal to the drag force constant times the velocity squared. Here we have the video of my experiment. As you can see, this lab is as simple as dropping a paper ball from any height. After uploading the video to Tracker, I was able to create a graph of the position versus time of the paper ball falling. As you can see, due to human error, the paper ball did shift towards the right horizontally a bit, and so that kind of made some errors in the graph. After that, I had to do some coding on GlowScript. The first code towards the left is the code without drag, and the second code is the one with drag, which is towards the right. And so for the first code, it really just goes over the like a general observation of something lightly falling with just gravity. And the second code takes into account of drag force with gravity as well. After that, I created a comparison between the computational without drag, and the computational with drag. The observe is just a video from Tracker and of me dropping the paper ball. And as you can see, because of the human error in that, it is significantly different than the computational with drag and the computational without drag. In conclusion, we use Newton's second law to find the motion of an object based on its net force. Because of some human errors during the experiment, there were some unexpected results in the end. The velocity did change because there was a net force present during this experiment. So, what does all of this mean? It means that the computational models with weight and drag force show the terminal velocity. Without drag force, there would not be any terminal velocity. Since terminal velocity is independent of initial velocity, the terminal velocity will not be different.